So first thing first, so let's talk about the T-curve. Okay, T-curve is a place that everybody starts with. So how the T-curve works? T-curve has 3 phases. Okay, when you talk about motion profile, so when you talk about the motion profile, the most important thing is how many phases it has. Okay, so different motion profile have more phases. So the lesser phases that it has, the easier it is. For example, the T-curve has 3 phases. What are the 3 phases? The first phase is acceleration, constant velocity, and after that deceleration. So phase 1, phase 2, phase 3. So in each phase, normally in each phase of motion profile, different equation is applied. For example, in the first phase of, for example, this motion profile, you have acceleration, but for example, you don't have, for example, deceleration. Okay, so in the next phase, you neither have acceleration or deceleration. In the last phase, you have only deceleration. So some of the parameters will be there, some of the parameters won't be there. Okay. So as mentioned, we need all this for the limiting it. So okay, so this one is T-curve, but the T-curve itself can be 2 types. So depend to amount of the movement that you have. Okay. If the movement that you have is very short, you cannot to reach to the constant velocity. So if you cannot to reach to constant, for example, imagine something like this: somebody asks you to do 1 cm, okay, do movement for 1 cm. In 1 cm, can you reach to 100 km per hour? No, you cannot, because even you need the acceleration of infinite acceleration to reach to the 1 km per hour to move 1 cm, right? So this is impossible. So that is the reason that you have something called triangle drive. Okay. Most of the motion profile, for example, except the sinusoidal one, those is because they are not multiple phases. So sinusoidal one, there are different kind of this. Some okay. So I would say like all the motion profiles, they could have a triangle drive. Okay, what is a triangle drive? It means that there won't be a constant velocity. If you see this one, he has a constant velocity on the middle, right? But if you see this one, there is no constant velocity on the middle. Okay, they call this one triangle drive. Okay, so this is, I love triangle drive. Okay, so for fast application, okay, for something like, for example, like construction or something like that. Now I'm entering construction, so the what they call it, the startup that I'm doing robotic for construction. Okay, so I'm sharing this one as a site hustle. But in the construction, for example, most of your movements is something like this. It means that they have a slow acceleration. After that, for example, they have a constant velocity. So why? Because things are slow. So in something like construction, you don't want fast. You want to be strong and safe. This is the 2 things that you care about in construction. You want a strong and safe. It's a slow process. So normally you have always constant velocity, those kind of things, and you have, for example, but if you are, for example, my original background is in semicon. So in something like a semicon, okay, you don't want a slow and safe. So you want safe, but it is not, the safe is not like safe, because for example, over there everything is small and nothing can kill somebody. A maximum you can lose a finger or two. This thing happen. I have a colleague that lose fingers. So, but maximum, okay, worst come to worst, for example, you lose a finger, or you lose for example, eye or something like that in semicon. Okay, but in construction, if you do a mistake, the entire building can come down. So yeah, so the safety in semicon and safety in construction is different. Okay, so and in semicon everything is small and fast. Okay, in construction is everything is heavy and slow. Okay, so this is the reason why that when you are in semicon, triangle drive is very common. Okay, more it means that in most of the movements that I do, I will try achieve to have triangle drives. I say why I would say why I prefer triangle. If, for example, imagine I have profile A and profile B. Okay, that one of them is triangle drive, one of them is full drive. Okay, both of them achieve the same timing. Okay, so, and for example, I'm optimizing for speed and so on and so forth, this kind of thing. Okay, between that, both of them, the cycle time for both of them the same. Between that, for if you ask them to go from point A to point B, both of them take same amount of time. Okay, so if you ask me to choose full profile or triangle drive, every single time with blind eyes, I would always choose triangle drive. Later I will explain why I choose triangle drive. The reason that I'm choosing triangle drive is that because it's triangle, when you achieve the same thing, it means that you want to achieve the same performance. Okay, when it's a full profile, you have to accelerate higher. Okay, it means that you have to put more torque and those kind of things. So torque is always issue. Okay, torque, because torque is, you are fighting with inertia, you fighting with mass, those kind of things. So that is a very energy consuming, power consuming kind of things. So that is the reason that every time, for example, they ask you that, for example, you can do a, for example, triangle drive or full profile. I choose a triangle drive because the triangle drive, you can make the acceleration lower, do the same distance, but the acceleration is lower. When the acceleration is lower, you are not fighting inertia or torque. Okay, so this is a very wonderful thing. Okay, so it is much easier to tune. Okay, so later in the next videos I will explain about the tuning, those kind of things also. But this is something very beautiful. So always choose for triangle drive. Okay, so okay, if you have a choice between the triangle drive and the full profile, which one you choose? Think about it. Triangle drive. Okay, so if you say triangle drive, I'm so proud of you. So okay, so let's go about the equations for the motion profile. Okay, so this one is a very basic motion profile, this kind of thing. So this one is the, what does this one means? Okay, O is acceleration, V is the initial velocity, and X is initial position. So these formulas, it's what these formulas say is say that at each time, this one is a general formula. Okay, when you're doing the motion profile, so some of these things, for example, will become zero, some of them they will become negative, and those kind of things. But the general thing that it says is that, for example, if at any moment of time you can find your location based on these parameters. Okay, for example, okay, if you have your initial acceleration, initial velocity, and initial position, if you put it in here and you know the time, you can calculate your position. Same for velocity, same for acceleration. Okay, so this one is very basic version. Okay, for TCAP is very easy, so you don't have many parameters. So X is displacement. By the way, this one also I share it down below. So this one I will make it open source, you guys can access, so you can see. So velocity, acceleration, and time. So okay, so this one is a general formula, but in each phase this formula will change. So okay, for example, imagine we go to the original one that I draw here. Okay, so imagine I have something like this. I copy the guy, copy the boy. Yeah, I copy the boy and I place it here. So okay, so if for example you have this phase, okay, so this one is first phase one, phase two, phase three. Okay, so imagine in a phase one, the equation is very simple. Okay, in the first phase, I don't have an initial velocity. You see, initial velocity is zero. After that, I don't have, for example, okay, so if you see my formula, okay, I don't have initial velocity. After that, I don't have initial position. I don't have anything. So that is the reason that if you see my, let me add this one so you guys can see the thing very properly. Okay. So if you see my original formula for, so everything will cancel out, right? So I don't have initial velocity, I don't have initial position, I don't have anything. So it's become very simple. It means that become 1 over 2 RT square. Okay, my velocity will be RT and my acceleration would be equal to the original acceleration. Simple as hell. So this one is so beautiful, so easy. Okay, so for the second one, okay, so I don't have any acceleration because it's a constant velocity, right? I don't have, so you see acceleration is zero, okay, but I have a constant velocity. Okay, so what would be my position? So the position would be the position of the previous phase. So because I have my position is no longer zero, right? So previously I accumulated some position in phase one, okay, plus the velocity times t, okay, and my so this one it would be my position. Okay, so this one is wrong. Yeah, so this one also is v. Okay, so this one also is, so this one is wrong. So yeah, so the O is zero. Okay, so this one is the correct formula. So please please forgive me for the mistake. On the last phase, how it's going to happen? On the last phase, you see that the acceleration would be negative. So you see we have a negative acceleration. So just we substitute. But in this one, we have everything. We have the velocity, we have constant velocity, we have the position, we have a position from the phase one and phase two. So both of them accumulate, and we have a negative acceleration. Okay. And here also we have a negative acceleration. And so this one, it would be the V minus RT, I think. Yeah. No, this one is wrong. This one is wrong. This one is wrong. Definitely, this one is. Yeah, this one. Yeah, this one is correct. I don't know why I copy this one. Okay, so the V is equal to negative RT. Yeah, all is, yeah. So this one is correct. Okay. So this one you don't need to know because this one is more advanced. So this one is more advanced. This one is for trajectory calculation, how we do the trajectory calculation. Okay, so this one I'm explaining over there. Okay, so this one is you basically just understand what it is. Okay, but how to do this one in the code. Okay, so normally when you do these things in the code, it become two-part algorithm. So this one later, because I'm doing the thing for the construction, I'm gonna develop it anyway. Okay, so I make it open source. You guys can see the code how the things is implemented. Okay. Please like, share, and subscribe. Huh? This one is a wisdom that I gained over years. I'm giving you for free, you know. So yeah, so I really appreciated that. Okay. So how to solve this thing in a real code? So in real code, normally this thing it become two part. Okay. One is trajectory planning. Another part would be trajectory streaming. Okay. So what is the trajectory planning? The trajectory planning is that you have to decide that how long would be each phase. Okay, first of all, do you have all the three phases? Okay, or you have only two phases? Okay, so three phase and two phase, it was this one. Okay, you remember? So I said that some of them, if the position is too small, you have three phase or two phase, right? Okay, so this one I show you how to do this one in a code. Okay, so is it three phase or two phase? Okay, and after that, if it's three phase, each phase, how long does it take? So the first phase, for example, 1 second. The second phase, 2 seconds. After that, the third phase, for example, 1 second again. Or for example, different. Okay, so I don't know, 2 second, 2 second, 2 second. Okay, so you have to determine the amount of the time. Okay, so it means that in the trajectory planning, you are checking that, okay, how your motion profile is supposed to look like. Okay, so you calculate, you are planning it. Okay, you are not executing anything, you are planning that how you want to travel this road. This one they call it trajectory planning. Okay, how about the second part? And the second part is trajectory streaming. Okay, so the trajectory streaming is that when you do the trajectory planning, the trajectory planning is a difficult part of the day. Okay? Especially for example, something like T-curve is not difficult. Okay, it's piece of cake. And if you are, for example, already scared with the things that I show you, come on, you have to see the things that I'm gonna show you in the future. Those things we can go out of control very fast. Okay? So the equation become very complicated. The trajectory planning. Okay, so the first one is very easy. So this one is very straightforward. The trajectory planning for TCAP is very easy. But in general, the trajectory planning is difficult part of the day. You know that you plan the thing is difficult. The moment that you plan, okay, execution is easy. The execution is that all those formula that I told you, right? Okay, so you already know, for example, in the first phase, I have this, I have that, I have the other one. Okay, what you do is that just you every 1 second, for example, whatever it is your cycle time. Okay, so this one also you have to be a real-time system. Okay, so you have to be deterministic and you have to be real-time system. It means that you have to have a, for example, cycle time. In every cycle, for example, at a 1 second, 2 second, 3 second, 4 second, you will come and calculate all the formulas that I told you. And based on that, you say that, okay, the position is supposed to be this, velocity is supposed to be this, acceleration is supposed to be this. Okay, and after that, this one you normally feed it to your PID or your control system or something like that. So those, they will use these values as a target to control the motor. Okay, motor or actuator or whatsoever it is. Okay, so this is the things that it is going on. This is the way that it is, the thing is executed. And another the most important thing about this thing is that the switching part between each phase, because the formula for each phase is different, right? So in each phase, for example, the first phase and the second phase, you have to, in the trajectory planning, you are calculating at which moment you have to switch from the phase 1 to phase 2, phase 2 to phase 3. Okay, so this one, it will help you to do that, so you can stream the position. Okay, so after you do this, so you will reach to the second phase. So this one is the second phase, so two phase one. So this one is a triangle drive one. The triangle drive one also is like a previous one, just simpler and for fast application. Okay, fast, small, point to point. This one also another topic. This one is something that I always force people to remember. I was used to teach people. Okay, so I think for this tutorial is too enough. This one, I think it become already too long. I don't want to talk too long. Okay, so in the next tutorial, I will talk about the T-curve low pass filter, and I go to S-curve, those, and this kind of thing. But this one, I think, is a good general overview for the first video. Okay, so this is way better than enough. Okay, so please like, share, and subscribe. Okay, so your like and share and subscribe help us to get clients on Upwork and all these freelancing jobs. Okay, so I'm coding for food. Okay, I really have I have really financial issues and those kind of things to sustain as a guy who is working on his own startup. So your help by like and share and subscribe, you will let us know that you want us to continue these videos, And beside that, also get us clients on Upwork and those kind of things to make money and be able to continue this. So please don't forget that. And up to next video. Thank you. Bye.